All right, guys, here we go. We're going to start talking about, okay, finding domains and range of functions. This is involved with your section 3.1, okay? Now, here's our good friend, the square root of x. We already know his domain is strictly positive, and the range is strictly positive. How do we know that the domain is just positive? Because we know that we can only take the square root of positive numbers. So there's a restriction that's stated. The restriction is that whatever underneath the square root needs to be positive. So x greater than 0 is a restriction which dictates what the domain is. Therefore, that dictates what the shape of the graph is going to be. We already know the range is likewise the same, and we know the symmetry is non-existent. So we take something a little bit different. Okay? We say, well, then what is going to be the domain of this function? The square root of 2 minus x. Well, we go back and we see what we did over here. This had a restriction. The square root of something has got to be positive. So whatever underneath the square root needs to be positive. Well, what's underneath the square root over here? 2 minus x under the square root. So it needs to be positive, which means that expression, that which is under the radical sign called the radicand, must be positive, which says it must be greater than or equal to 0. When we solve that for x, okay, we should simply subtract 2 off of both sides. Then we divide by -2, and that will tell us the restrictions on x, okay, which says that x has got to be less than 2, which is telling us what the domain of this function is going to be. It's going to be everything less than 2. That is from -infinity to 2. Now, we know what the domain is, okay? Let's take a look at the graph, because the graph should be in agreement with that. There it is. There's the graph. The graph is only defined for the x values less than 2, okay? You can't try to put something in. Go ahead. Put a 5 in. What do you got? 2 minus 5, that's -3. Square root of -3 doesn't exist. No kidding, okay? Because the graph's not defined there, all right? So, when you have radical expressions, you must assure that whatever underneath the radical is positive. So that's the restrictions. Solving that helps us define the domain. Take a look at this guy. This we know is our unit circle, defined this way. Well, what's underneath the radical sign? 1 minus x squared. Well, 1 minus x squared must be positive, okay? Well, let's see why. We know that it must be positive. Let's work it out. Here it comes, okay? So 1 minus x squared must be positive. We know that. So we're taking the square root of something. It's got to be positive. So there it is. We put that restriction in place. What do we do now? Well, how do we resolve that? Well, we just did that. It's called a sign table. But better yet, we'll show you a way of not having to do the sign table. I always like to have my expressions written x first. So I reverse this order. And then I say, well, I don't like to lead off negative, so I pull out the negative. Now what am I going to do? I'm going to divide both sides by negative. Now, x squared minus 1 needs to be greater than 0, needs to be less than 0 now, because I divided by the -1. Now, I could do a sign table on that, but I know enough about the graph of what x squared minus 1 looks like, and I know that that's going to look like that, and I know it's going to dip below the axes between 1 and -1. Therefore, I'm able to validate that the domain of this function, okay, is everything between -1 and 1. Lives in a small little world, because what is under the radical sign, okay, must be greater than 0, okay? And we'll look at a little bit more involved on that, as you might well imagine, okay? Here's our good friend 1 over x. Not defined at x equals 0. Okay, we accept that because we know x can't equal 0. Can't divide by a negative, right? Or it can't divide by 0, mind you, okay? So we know the domain is everything but 0. So we're not asking what it is not, we're asking what it is, which is everything from -infinity to 0, and then from 0 on out, so long as we don't include 0. We say the range is that, and you're going to say, well, how did you know that? Well, we're going to come to that in a moment, so just bear with us, okay? But what we're going to do is we're going to take a look at something a little similar to this. In other words, we're going to take a look at this expression, and we're going to say, well, what is the domain of this? Well, again, if you've been listening from day one, before you tell me what it is, you tell me what it is not, and it is not -3. We know that, okay? You better know that. You said that from day one, okay? Well, if it is not -3, what is it? Well, it's everything but -3. So there's the domain, everything but -3, yes? And there's the picture. And you'll say, well, how am I supposed to get that picture? Well, that will come. That will come in time. But at least we know it's not equal to -3. That's why we get that asymptote behavior right there at -3, okay? That asymptote behavior is never going to be -3. Can't be, okay? Take a look at something like this, all right? You'll say, what is the domain? Well, again, what is the domain is easier to tag what it is not rather than what it is simply by factoring. So by factoring, we say it is not -1 and it is not 5. Well, what is it? If it is not those, it's everything but those, okay? There's what it is not. What is it? Everything else but those, okay? There it is. There's how you tag everything else. You don't include 5 and you don't include -1. Yes, it's easier to write what it is not, but the domain is asking what it is. And what it is -infinity to -1, then again from -1 to 5, and then again from 5 to infinity. And look what happens. Where it is not allowed to be those values, we find we have those asymptotes. Those asymptotes occur. You'll say, I'll never be able to graph that. Sure you will. You'll have to. Not right now, though. Let's just worry about finding the domain, and then we can worry about the graphs of how we get those graphs later. At least I'm just showing you now that the implications of the graph is we got that asymptote happening there because it is not equaling 5 and it is not equaling -1. Okay? Let's look at another one. Okay? Oh my God, no, not that. Yes, that. We're asking for the domain of that. Are you serious? Yes, I'm serious. Well, wait a minute. You're taking the square root. The square root of something must be positive. Okay, so I know the square root must be positive, so it starts with this. What do we do with that? What do you mean, what do we do with that? We just done those problems. That's called a sign table. Oh, please. Yes, please. You must create a sign table in order to solve this inequality. Why do I want to solve this inequality? Because you're asking for the domain. What is the domain? Well, I know there's a restriction because I can only take the square roots of positive. So therefore, the radicand, that nasty expression underneath there, must be positive. It must be positive. So here it is. Okay? Set it up. Solve it. So you have to do it. You have to create the sign table. All right? So it's factored. We know it's not allowed to equal -3 or -2. What's going to happen there? What do you think? What's going to happen when the denominator zeroes out? We saw in the previous graphs what that put on the graph for you. Okay? Well, let's go. We have to do the sign table. No way around it. Let's do the sign table. Here we go. The sign table built on this expression. When is that greater than 0? Okay? So here it is. Here's the expression. That needs to be greater than 0. There it is in factored form. Okay? Here's the sign table coming. All right? Hopefully this should not be an issue trying to generate this sign table at this point. Now we know why we need to generate those sign tables. Okay? Because what are we after? When are the products and quotients of these factors greater than 0? When are they positive? There we go. There's one tag right there. From -infinity to -3. There again from -2 to -1 and 1 on out. Okay? Now, so we know now what the domain is. We know the domain is those intervals, right? Now you ask, well, what would the picture look like? Okay, well, let's take a look. Not that we are going to hold you accountable for drawing the picture, not at this stage. In the future, yes, but let's take a quick look. Okay, we know there's going to be gaps in this because here we go negative, here we go negative, so there's going to be gaps. There's not going to be any graph between -3 and -2 or between -1 and 1. Take a look. Here it comes. Here's the picture. Here it is. Here's the picture of this function, right? just like we said, a gap between -3 and -2, and a gap between -1 and 1. Okay? How did you know that? Go back. Because you had to make sure what was underneath the radical sign was greater than, you had to make sure what was underneath the radical sign was greater than 0, okay? Which we did our sign table for, and lo and behold, when we got the picture, this is what resulted, okay? And again, that picture, okay, at least what we're trying to analyze now is the domain is exactly what we said. It's coming in from negative infinity. There's gaps between -3 and 2, and there's gaps between -1 and 1, as the sign table indicated there would be. Okay? All right. Okay? Then that's the domain of that function. All right. Now let's find the domain of this function. Are you kidding? The cube root? Well, you know what? It's the cube root of that same expression, isn't it? Yes, it's the cube root of the previous expression. Whereas the previous expression, we took the square root. Now we're taking the cube root. Well, guess what? That cube root's easier. Why? What do you mean the cube root's easier? Well, because we can take cube roots of negatives as well as the cube roots of positives. So guess what? There's no restriction on this function, or is there? Yes, there is, because we still cannot have the denominator zeroing out. We still are undefined at -3 and -2. But we don't need to do a sign table this time around because, all right, we're not worried about what's underneath the radical sign having to go positive or having to go negative. Because since it's a cube root, it can take on the cube root of a negative is defined, as is the cube root of a positive. So the only restrictions we had to worry about was the denominator zeroing out, which occurs at these values that we got from the factors, okay, which are -3 and -2. So therefore, this is what the domain is not. I'm not asking for what the domain is not. I'm asking for what the domain is. And the domain is, again, then it would be everything except those two values, which is expressed this way. Now you might say, well, what would that picture look like? Well, guess what? Let's come back. Let's go back to the square root where the restrictions were at -3 and -2 and nothing else. And let's see what this picture looks like. The cube root of that expression. Here it comes. Here it is. There it is. There you go. Okay? The only place where the function is undefined is at -3 and -2, and they're going to have those asymptotes. Okay? Now, again, I'm not asking you to generate that picture. Surely your calculator can, but it does support that which we were trying to test for. What is the domain of that function? Okay? And there you have it. I'm going to end the video on this note, okay? Having gone through and found how to find the domain of functions, okay? We have to be concerned about functions, okay, where we have to take the square root of something, and we have to be concerned about functions which are fractional in nature and being assured that our denominator did not zero out, okay? So we will resume in another video determining the range of a function. That is all for now.